So today we're going to be talking about the order of operations. When I look at our statement of inquiry again, I want to bring it back to the fact that this whole unit is really about solving mathematical puzzles, and that's by using simplification, equivalence, and logic. And so today the type of puzzle we're really going to be solving is going to be how to take an expression that looks crazy like this and make it significantly more simple by getting the equivalent answer, right? And we're going to do so with logic. So really, we're hitting all three of these keywords today. So this is review from last year. You did learn this in pre-algebra and probably 6th grade. The order of operations has to go in a really specific order. Math people a long time ago decided that it's got to go in this order. And the way we remember it is by saying gems. So let's fill this in. The G for gems would be grouping symbols. The most common grouping symbols that you're going to see in this class would be parentheses. The E for gems would be exponents. Exponents. And what is super important, crazy to remember about exponents is that it's those little numbers, right? So it's going to look like this. And this does not mean 3 times 2. What this means is 3 is being multiplied by itself 2 times, which means this would be 9. Now the last 2 steps of GEMS get a little bit complicated because kids always think that the M stands for only multiplication, but the simple fact is that GEMS sounds a lot better than GEMDIDS, because the M really stands for any multiplication and division. They're of equal importance. So I'm going to put a little slash. If you want to put the word and or, that's fine. Multiplication or division. And same deal, kids get to the S of GEMS and they think that it only stands for subtraction, but it's really talking about our 2 most basic math operations, which would be plus and minus, right? Subtraction and addition. Now, one super important note that I want you to add is, and I'm going to choose a really appropriate color here, I'm going to go with bold red. So our subtraction and addition and our multiplication and division steps oftentimes seem like the most simple, but we read math just like we read English, which is from left to right. So when you get to the step of multiplication or division, you start reading your problem from the left and you do the first multiplication or division that you see, then you keep going. So I want you to add a nice big note here and say from left to right, just like English. I would maybe even add a little arrow left to right. So let's take a look at an example. So example 1. Whenever I'm doing a GEMS problem, I personally like to just rewrite my steps, and then it's kind of a good indicator for me to be thinking. So do we have any grouping symbols? Well, yes, we do. So that's what's going to happen first. So I see the parentheses. I do what's inside the parentheses. 3, take away 3, it's going to be 0. Okay, I'm going to rewrite the problem. 5 minus that answer plus the other stuff here that we have not changed. So I've already done GEMS. I want to look again. Do I have any other grouping symbols? Nope. So I'm done with the G for grouping symbols. So next, do I have any exponents? Absolutely I do, right? I got this teeny tiny 2. So, just like we talked about in the formal definition of what GEM stands for, this is not 6 times 2. This would be 6 multiplied by itself 2 times. 6 times 6 is 36. So I'm going to rewrite the problem. Looks like there's still a divide 4 at the end. There's still a 5 minus 0 plus that. Next, do I have any multiplication or division? So I'm looking, no. Aha, I do. So this is what I need to do next. 36 divide 4 is 9. What's really important by the time we get down to these last 2 steps is after you take a step, I do want you to just double check, do I have any other multiplication and division signs? I see a minus sign, I see a plus sign, we're good. So last but certainly not least, we need to be doing our minus and plus signs, but again, this is from left to right, which means I don't care what's over here. I'm going to start with the very first thing. 5 minus 0 is 5. Now I am taking my last step, plus 9, 14. One thing to note is Ms. Powers is a math teacher. I do math in my head all the time. You are absolutely allowed to use a calculator during this unit. So if you didn't love this 36 divided by 4 part, how quickly I did that, fine. Type it into a calculator, totally fine. Let's go ahead and take a look at our next example here. So I know it seems silly, but again, I'm going to write out GEMs. And as I'm looking, do I have any grouping symbols? By golly, I do again. So this is the first thing I'm going to do. 1 plus 2 is 3. I'm going to rewrite the problem. So when I'm asking myself, am I done with this step, it might be a little tempting to say, I'm not done. Look at that, 3 is still in the parentheses. And good point, right? Because a grouping symbol would be those parentheses. But when I look at it, there's a single number in it, which means there's no math to be done within the parentheses. When I say G for grouping symbols, what I'm talking about would be math within the parentheses, just like how we had 1 plus 2 inside here. I have no math inside here. It's just a number. So I know that I'm done with the first step. Okay, next step. Do I have any exponents? Yes, I do. So I would suggest you write this out. This means 3 multiplied by itself 3 times. So 1, 2, 3. If you want to grab a calculator, go for it. Otherwise, I just take this in parts. 3 times 3 is 9, and then 9 times 3 is 27. So 3 to the 3rd power must be 27. Now I'm going to rewrite the rest of it. Okay, I double check. There's no other little tiny exponent numbers hanging out, so I must be done with that step. Now, when I'm looking for my multiplication or division, remember I'm looking from left to right. So I see a 27, I see a minus sign, and then I see this. So one super important fact about mathematics is if you see a number or a letter or anything sitting directly next to a parentheses, right? I see this 8 touching the outside of this parentheses. That means that those two things are being multiplied. So if I wanted to, I could write this as 8 times 3 without the parentheses. Math people just decided that a parentheses shows multiplication like that. So do I have multiplication? You betcha. 8 times 3 would be 24. Rewrite the problem. At this point in time, it's looking pretty obvious what my last step is because it is one thing. 27 minus 24 would be 3. Now, what I want you to do, because I don't want to make a 27-minute video that's going to be super boring, I'm going to stop the video here, and it's your job to do example 3. I'm going to post example 3, how to do it, in the very next video. So I want you to stop this video. It's going to stop automatically in a moment. And I want you to try example 3 by yourself. Then watch the next video and check your work.